Welcome to the second part of the explanation to this second set exam paper. Now, question 11. Now, AIDS and syphilis are both sexually transmitted infections, or STI for short. Now, which of the following correctly compares the two STIs? Now, we understand that here they say AIDS can be inherited genetically, but syphilis cannot. Now, actually, this is wrong. Syphilis can be inherited as well. Now, both are caused by viruses. Now, this is not true. For AIDS, yes, it's caused by virus, but for syphilis, right, it's actually by bacteria. Now, both syphilis and AIDS attack the immune system of the infected. That's not true, okay, because AIDS will affect the immune system, but syphilis, it doesn't. Okay, so the answer is actually D. Syphilis can be treated with antibiotics, but AIDS cannot. Okay, question number 12. Now, the diagram shows a series of events happening in the female reproductive system. So, which of the following correctly labels X and Y? Now, we can see that over here, this is a sperm. Okay, and you have the ovum. Okay, so what is happening is once the sperm fertilizes the ovum, we will call it this zygote. So, this term zygote, it means fertilized ovum. Alright, so for this X, right, this will be the zygote, and when it starts to progress to this stage, you can see there are many cells. This is multicellular, right? Multicellular, and once it becomes a multicellular, we actually call it the embryo. Right, so this is the embryo. Okay, so our answer will be C. Alright, zygote and embryo. Now, how about fetus? Now, fetus is actually maybe after 9 weeks, right, onwards, then it will be considered as a fetus. Okay, so in the beginning, we don't really consider it as a fetus all the way until the 9th week, then we can consider it as a fetus. Alright. Okay, question 13. Which of the connection will give the biggest total resistance? Now, it's either series or parallel, but if you want the biggest total resistance, of course, it must be series. Alright, straightforward. Next, question 14. An electric lamp is marked 250 volt, 1000 watt. What is the current that is passing through the lamp, and what will be the most suitable fuse rating? So this question actually asks us about the current and also the fuse rating. Now, we understand that fuse must be slightly larger than the current. Just slightly, okay, not too much. So we first find the current. So current, it will be equals to power divided by voltage. And that will give you 1000 divided by 250. So that's 4 ampere. So this C and D will be possible, but you want it to be slightly bigger for the fuse, so answer must be D, alright, because it cannot be lower than 4. Once it's lower than 4, the fuse will, they will actually short circuit they will create a break in the circuit, alright, because the thin wire inside the fuse will burn, alright. Okay, next, number 15. Now, the diagram shows a U-tube partially filled with mercury left in the atmospheric pressure. What will happen to the level of mercury in the U-tube if arm P is connected to an air pump to fill space above the mercury with more air? Now, if you have more air, alright, so this will have higher pressure. Okay, maybe I should say more pressure. Okay, increased pressure. So when you have increased pressure, what is happening is there will be a force, right, pushing the water level. It will push the water. So in turn, it will actually push the water upwards, right? So the answer will be A. The mercury level in P will drop while mercury level in arm Q rises. Okay, question 16. The gravity of the moon is 1/6 the gravity of the moon. The gravity of the moon is 1/6 the gravity of the Earth. So if the mass of an object is 50 kg, what will be the mass on the moon? Now the mass remains unchanged, all right? So it will still be 50 kilogram. However, if they ask for the weight is dependent on the gravity. Since the gravity of the moon is 1/6 the gravity of the earth, so the weight of the object will be 1/6 the weight of the on the earth. Question 17. Now, MRT travels at the speed of 80 km per hour. How long it will take for the train to travel from Boon Lay to Pasir Ris, where the distance is 38 km? Now, this is your math question. So, we use DST to find the time. All right. So, time, you take distance, which is 38 km, divide by the speed. So, speed is 80 km per hour. Now, you end up with 28.5 minutes. Of course, you will get 28.5 over 60. That will be equivalent to 28.5 minutes. Question 18. The fish hangs on a spring balance as shown. So which statement is correct? Now I see this spring balance, the unit here is newtons, which is the unit for force. Okay, unit for force. And of course they are measuring weight. Okay, they are measuring weight because weight is a force, a type of force. So we can say that the weight of the fish is actually, so you read, this is 1.5. Now the graduation, every unit is 0.1, so 1.6, and this will be 1.7. All right, so it will be 1.7 Newton. So answer is C. Okay, number 19. Stored energy is described as potential energy. Now, potential energy is dependent on, of course, the easiest way to illustrate it is depending on the position. So anything that is, we take this as a level 0, all right, where potential energy is 0. Okay, so here if I say PE is 0, anything that's higher, all right, higher ground, so the PE will increase. So over here, if you look at the first option, football at the tip of its flight, of course, is going upwards, right? There's an increase. So this one, there is potential energy involved. Football traveling along the ground after being kicked. So if it's staying on the ground, right, you have the ball here, it goes along the same level. So there's no change in the height. That means there's no PE involved. So answer will be B. But if you look at C, raise his leg, again, raising his leg means you have like an increase in the height, so it cannot be C. A net stretched by a fast-moving football. Now this is actually elastic potential energy. Okay, it's slightly different from what I have explained earlier, but there is still PE involved, so answer must be B. Now question 20, which of the following actions involves the energy conversion from elastic potential energy to kinetic energy? If you look at the diagram here, this part is when it's aiming, right? There's nothing that is moving, so there's no conversion. Okay, so no conversion. Drawing the bow, so when he's pulling the bow here, I think you will be using up the energy from the food that you consume, right? So we consider it's a chemical energy, all right, and you convert it to maybe KE, and more importantly, it's a EPE, right? So it still doesn't change from EPE to kinetic energy, all right? So these two options are out. Hitting the target, well, when you have the bow, the arrow, just about to hit the target. Now this is definitely moving, all right? So when it hits the target, perhaps there is some change in there's some stretch in the fabric. Okay, so maybe there is some KE converted to EPE. So I can say KE maybe converted to EPE, of course, plus sound, and maybe heat. Okay, but still it is not what they want, because they want EPE to KE. So this is out. But the last one, when he's releasing the bow, so just before he release the bow, you can see that the string here, they are being stretched. All right, the bow over here again is bent as well. So there's a lot of elastic potential energy being stored. And once he release, the arrow will actually move at a very fast rate. So there is a change in kinetic energy. So we say EPE converts to KE. So the answer will be D. Okay, I will stop here. So I will have the part 3 in a short while. So please look forward to that.